Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Data Reconstruction and Restoration. Data reconstruction and restoration have become critical components in the realm of data engineering, particularly as organizations strive for data storage optimization. With the proliferation of data-driven applications, the ability to efficiently reconstruct and restore data can significantly impact the performance and accuracy of these systems. Generative AI offers innovative solutions to these challenges, providing tools and frameworks that facilitate the efficient management of data storage and retrieval processes. This lesson delves into the actionable insights and practical applications of GenAI in data reconstruction and restoration, highlighting tools, frameworks, and methodologies that professionals can implement to address real-world challenges. At the heart of data reconstruction and restoration is the need to recover lost or corrupted data and optimize storage systems to prevent such losses in the first place. Data loss can occur due to various reasons, including hardware failures, software bugs, and human errors. GenAI, with its advanced algorithms, can predict potential data losses and offer solutions to restore the data to its original state. For instance, machine learning models can be trained to recognize patterns of data corruption and automatically trigger restoration processes. This proactive approach not only minimizes downtime, but also ensures the integrity of the data. One of the primary tools in GenAI for data reconstruction is the use of deep learning models, particularly neural networks designed for anomaly detection and data imputation. These models can identify missing or corrupted data points and reconstruct them based on learned patterns from the dataset. For example, autoencoders, a type of neural network, can be employed to compress data into a lower dimensional space and then reconstruct it, effectively filling in any gaps in the data. This method is particularly useful in scenarios where data integrity is crucial, such as in financial and healthcare sectors. Moreover, frameworks like TensorFlow and PyTorch offer robust platforms for developing and deploying these deep learning models. These frameworks provide pre-built modules that simplify the process of model training and deployment, allowing data engineers to focus on optimizing the models for their specific use cases. By leveraging these frameworks, professionals can accelerate the development cycle and enhance the accuracy of data reconstruction processes. In addition to neural networks, GenAI can utilize reinforcement learning to optimize data storage and retrieval systems. Reinforcement learning algorithms can be designed to learn optimal strategies for data backup and restoration by interacting with the environment. For instance, a reinforcement learning model can be trained to decide the best times to perform data backups or the most efficient methods to restore data, thereby reducing the overall cost and time associated with these operations. A practical example of this can be seen in cloud storage systems, where data is often distributed across multiple servers. Reinforcement learning can optimize data placement strategies, ensuring that data is stored in locations that maximize retrieval speed while minimizing storage costs. This not only enhances the efficiency of the storage system, but also improves the user experience by reducing latency during data access. Case studies highlight the effectiveness of these approaches in real-world applications. For instance, Netflix employs machine learning algorithms to reconstruct corrupted video files, ensuring uninterrupted streaming services for its users. By analyzing historical data on video file corruption, Netflix's algorithms can predict potential issues and proactively take corrective actions, demonstrating the practical benefits of GenAI in data reconstruction and restoration. Furthermore, the integration of GenAI with existing data management systems can lead to significant improvements in data storage optimization. By utilizing AI-driven analytics, organizations can gain insights into their data usage patterns and identify areas where storage efficiency can be enhanced. For example, AI can analyze access logs to determine which datasets are frequently accessed and prioritize their storage in high-speed storage media, while less frequently accessed data can be archived in cost-effective storage solutions. This strategic approach to data storage not only reduces costs, but also ensures that critical data is readily available when needed. Another aspect of data reconstruction and restoration is the use of blockchain technology for data integrity verification. Blockchain provides a decentralized and tamper-proof ledger that can be used to verify the authenticity of data. By integrating blockchain with GenAI, organizations can ensure that reconstructed data is not only accurate but also verifiable. This is particularly important in industries where data authenticity is paramount, such as in legal and compliance sectors. The application of GenAI in data reconstruction and restoration is not without its challenges. One of the primary concerns is the computational resources required to train and deploy AI models. However, advancements in cloud computing and distributed computing frameworks have alleviated this issue to a large extent. Platforms like Google Cloud AI and Amazon Web Services offer scalable solutions that allow organizations to harness the power of GenAI without the need for significant upfront investments in hardware. Moreover, the ethical implications of using AI for data reconstruction cannot be overlooked. As AI models become more sophisticated, there is a risk of generating synthetic data that may not accurately represent the original data. This can lead to biased outcomes and decisions, particularly in sensitive applications such as healthcare and finance. Therefore, it is crucial for organizations to implement rigorous validation and testing procedures to ensure the reliability and fairness of AI-driven data reconstruction processes. In conclusion, GenAI offers transformative solutions for data reconstruction and restoration, providing tools and frameworks that enhance the efficiency and accuracy of these processes. By leveraging deep learning models, reinforcement learning algorithms, and blockchain technology, organizations can optimize their data storage systems and ensure data integrity. However, it is essential to address the challenges associated with computational resources and ethical considerations to fully realize the potential of GenAI in this domain. As technology continues to evolve, the integration of GenAI in data engineering will undoubtedly lead to more innovative and efficient data management solutions. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UExcel, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.